Alright, the goal of this video is to learn how to solve a system of linear equations. Well, there are several methods to do this. So first of all, let's take a look at the graphing method. Before we start, we have to understand what a system of linear equations is. Now each of these two equations, y equals 5 minus 2x and 3x minus 2y equals 11, each one of those is a linear equation. The reason that they are linear is because each of their graphs would be a line. Now you can tell it's a linear equation also because they both contain an x and a y, and there are no exponents other than the understood exponent of 1. So thus we have a system, which means two or more, of linear line equations. And what we want to do is find the common solution to those two equations. So what value of x and y would solve the first equation and also solve the second equation? There will be at most one intersection point or one common solution, unless of course it's the same line, which it isn't. So what we're going to do is graph these two lines and see where they cross, and that point where they cross will be the common solution. The first equation we're going to rearrange just a little bit and put it in slope-intercept form by just switching the x and the 5. So we end up with y equals negative 2x plus 5. The second equation, I have to work with that just a little bit more. I'm going to take the 3x to the other side. It becomes negative 3x, then plus 11, and divide everything by negative 2, so I get y equals 3 halves x minus 11 halves. Alright, now what we're going to do is go to the graph both of those lines. The first line, y equals negative 2x plus 5. The intercept is up 5 on the y-axis. I put a dot there. The slope is negative 2. Remember, slope is rise over run, so a rise of negative 2 over 1. So I go down 2 units, 1, 2, and run 1 to the right, and put a point. Now those 2 points will give me the line if I connect them, but I'm going to do a third point just to help me keep this line a little neater and more accurate. So I went down 2 and over 1 twice. I'm going to take my ruler here and draw that line in, hopefully as accurately as I can. And there's our line for the first equation. Second equation, it's all ready to go, except I'm going to switch colors here so we can tell the difference between the two lines. Okay, this one is y equals 3 halves x minus 11 halves. So the intercept is negative 11 halves, which is negative 5 and a half. So I go down 1, 2, 3, 4, 5 and a half on the y-axis. Put a red dot. And then the slope is 3 halves. So I'm going to rise 3 units, 1, 2, 3, and run 2. I'm going to do that again. Rise 1, 2, 3 units and run 2. Again, I want that third point just to make the line a little more accurate if possible. And now I'm going to draw that line, connecting the points. And thus we have the two lines from the two linear equations. Now their common solution, intuitively you would guess it's where the two lines cross, because that point is shared by both lines. So we can figure out the coordinates of that point where it's yellow highlighted, and it looks like to be 3 comma negative 1. So we have solved the system of equations by graphing. That point will solve both equations, and if you want to be absolutely sure, you could take 3 negative 1 and plug it into both equations, and you would see, hopefully, that you get the right answer. Well, the graphing method works. It's not the most efficient method, and the reason is because sometimes the lines, it's really hard to tell where they intersect, especially if it's at a fractional value. You can't tell if it's a half or a third or whatever. So we want a better method other than graphing to solve the system of equations. In fact, we'll take a look at 2 more methods that you should be familiar with. And the first one will be what's called the substitution method. So I'm going to erase some of this stuff up here and go back to my original 2 equations. Alright, the substitution method means you get either variable, x or y, by itself in either equation. So since the first equation has y by itself, or it's solved for y, we know that y is equal to 5 minus 2x. We can take that y value and plug it into the second equation for y. So instead of having 3x minus 2y, I'm going to have 3x minus 2 times 5 minus 2x. So I'm substituting 5 minus 2x in for y, and now I'm going to solve this equation. So we just go through our solving equation techniques here. Watch out for that double negative, becomes positive 4x. 3x plus 4x is 7x. I'm going to add 10 to both sides and get 21. X dividing both sides by 7 will equal 3. Now once you have an x or a y, whichever one you get first, to get the other value, you just take that 3 or whatever and put it back into either equation to solve for the other variable. Well, I'll just stick with the first equation. Y equals 5 minus 2x. Y equals 5 minus 2 times, replace x with 3. Y equals 5 minus 6. And y equals negative 1. Well, how about that? We got the same answer we got when we graphed it. So I think that method probably would be a little faster in this case instead of graphing. So that's called the substitution method. That's one of 3 methods that we need to know here. First being graphing, and second being substitution. And now the third method we're going to use for solving a system of linear equations, as soon as I get all this stuff erased off the screen, it's called the elimination method. Sometimes it's called the addition method, but the proper term is really elimination, because you don't always add, you can subtract. And let me switch colors here. Let's go blue. So this is the elimination method, and the object is to eliminate, thus the name, either x or y. Now the first thing you have to do is get both equations in the same form. I lost my y on my second equation. Let me put that back in. It's blue now, but that doesn't matter. So the first equation, I'm going to bring the 2x over to the left. 2x becomes positive plus y equals 5. The second equation is 3x minus 2y equals 11. Alright, now I've got both equations in the same order, in the same form, which is called standard form. At this point, I determine which variable I want to eliminate. Now to determine that, what I like to say is go with the variable that has the smaller coefficients. So if you notice, the x's are 2 and 3 respectively, and the y's are 1 and negative 2. So I'm going to work with the y's. It's just usually a little easier to eliminate the smaller numbers. You can do either one. Now in order to eliminate that, what we need to do is take the first equation, follow the arrow, and multiply it through by 2. So I'm multiplying the entire equation by 2, and I get 4x plus 2y equals 10. The second equation is going to remain unchanged, and at this point you will see why we did what we did. The object is to eliminate x or y. Now if we take these two equations and add them together, you will see that the y's are eliminated, or they drop out, because 4x plus 3x is 7x, 2y plus negative 2y is 0, and 10 plus 11 is 21. And guess what? There we go. Yep, same answer. X equals 3. And again, like in the last method, you can just take that 3 and substitute it in either original equation. In fact, you can go anywhere. You have 4 choices, so actually 3 choices. Y equals 5 minus 2x. We could go back to that one. We could use the second one, or we could use that one. But once you plug in 3, you would see that y again is equal to negative 1, as in the first 2 trials. So there, you've seen all 3 methods, either by graphing, substitution, or elimination, and everyone should be able to use those 3 methods to solve a system of linear equations.